Alright, this lesson is about direct variation, so let's see what happens. Alright, so direct variation, it's a relationship between the x and the y that is actually constant. However, as one variable increases, the other must also increase proportionally. Or, if one variable decreases, then the other must also decrease proportionally. So whatever x does, y must also do. And it must do so in a proportional way. So as an example, if you drive 70 miles per hour on the Dallas North Toll Road, and then the total distance you have traveled is proportional to the speed. So let's look at a table of this data. If I'm traveling 70 miles per hour, I can quickly generate a table. If I have driven no time at all, I will have traveled no distance. But if I've traveled, say, 1 hour, I will have traveled 70 miles. And 2 hours, it would be 140 miles, as long as I continued that speed. I can also take a look at the proportionality of this table. And this is how we're going to know if this is direct variation or not. So I check the proportionality by setting x is to y as x is to y and checking to see if the two fractions are equal. So I'm setting up my ratios of x to y. So my first ratio would be 1 to 70, and my second ratio could be 2 to 140. If I check with a calculator, these two expressions are equal to each other. So we do have proportionality here. And as the time increases, the distance increases as well. So this is definitely a direct variation. Another thing we can look at is the equation of the direct variation. In this case, the equation is y equals 70x, because for each hour we drive, we travel 70 miles. And finally, we can also take a look at the graph. So we just graph the 3 points, draw the line through it, and there it is. We will come back to the graph and to the equations at a later time in this lesson. Alright. However, what would happen to the total distance traveled if you were to actually cut your speed in half? So half of 70, that'd be 35. So I'd be going 35 miles per hour. That means in 1 hour I would only travel 35 miles. So that's actually exactly half of what we had before. So I guess that it would be half the distance. So if you cut your speed in half, you cut your distance in half. That makes sense if we're in a proportional relationship. Alright, well then, what would happen to the total distance traveled if you were to double your speed? Well, double 70, I get 140. And 140 miles per hour. So in 1 hour, I should travel 140 miles. Well, that's double what the original distance was. So again, if I double my speed, I need to double my total distance. That's because the relationship is proportional. So it is direct variation. Alright, another example. The number of tablespoons of sea salt needed in a saltwater fish tank varies directly with the number of gallons of water in the tank. A pet shop owner recommends adding 100 tablespoons of sea salt to a 20-gallon tank. How many tablespoons of salt should be added to a 30-gallon tank? We told you specifically that this varies directly. Therefore, we have some sort of proportional relationship going on here. So in order to figure out how much salt I should put in my 30-gallon tank, I do believe that I would probably set up a proportion. So here's what I would do. I would set up 100 tablespoons for every 20 gallons of water. That has to equal a certain number of tablespoons for every 30 gallons. I need to know how many tablespoons, so I'm going to solve for x. So just like we did in the past, we're going to cross multiply. 100 times 30 equals 20 times x. 100 times 30 is 3,000, and 20 times x is 20x. So then I just divide by 20 on both sides, and x has to be 150. So I need 150 tablespoons of salt for my tank. Alright, we can make a table for that previous situation and a graph. Well, so let's take a look at the table. We knew that we needed 100 teaspoons for 20 gallons of water, and we just solved the proportion and found that we needed 150 teaspoons of salt for 30 gallons of water. So this is our table. And then I'd take a look at the graph. Again, it's a line. And notice I added in 0, 0 on that line. Obviously, if I have no water, I don't need any salts. So 0, 0 is a logical choice. We can also take a look at the equation of this situation. The equation is y equals 0.2x. How did I get 0.2? Well, we know how to find the slope from a line. We also know how to find the slope from a table. So I did. I found the slope, and it came out to 0.2. All right, let's move on. For both examples that we've talked about, what do their graphs have in common? So I'm looking at their graphs, and ooh, I spot something. How about 0, 0? Both graphs pass through 0, 0. That's interesting. All right, what about, take a look at both equations and tell me what is true about both of them. Well, yeah, their slopes are different, but actually, it's the y-intercept. The y-intercept, because it's not written, must be 0. So the y-intercept of both equations is 0. So let's summarize about our direct variation. To check to see if something is direct variation from a table, all you need to do is check it to see if each ratio of x to y is the same. In other words, you're checking for proportionality. If you're checking to see if something is direct variation and you have a graph, all you need to do is look to see if the line passes through the point 0, 0. And last but not least, if we're trying to check to see if something is direct variation and we have an equation, then all we need to do is check to see that the y-intercept is 0.